Okay, draw a 1 by 2 rectangle. So I'm going to draw a 1 by 2 rectangle. And the original perimeter is 6 and the area is 2 units squared. Then I'm going to draw 3 different rectangles, each similar to the original one. So if this side's 2, this other side has to be 4. So that has a perimeter of 12 and an area of 8. Then I'm going to do triple the length. So down here it's 3, so it's a 3 by 6. So a 3 by 6 has a perimeter of 18 plus 6, 24, and an area of 18. And then the next figure I will quadruple. So 1, 2, 3, 4. 4 by 8. So a 4 by 8 is 16 plus 8. So 1, 2, 3, 4. 8 plus 8 is 24, and the area is 4 by 8, 32. So I must have messed up this dimension here. So the blue one has 1, 2, 3, 4, 5, 6. 6 plus is 18. And then the area is 3 times 6 is 18. Okay. So the similarity ratio. So the similarity ratio of the first to the original. So the similarity ratio is 1. The first one is 2. And the original one is 1. So if I look at the side length right here, the original one is 1 and the other one is 2. The ratio of the perimeters of the first, so the first figure has a perimeter of 12 and the original perimeter has a perimeter of 6, so the ratio is 2 to 1. Now if we can compare the areas, the first figure has an area of 8 and the original one has 2, so it's 4 to 1. Now I'm going to do the second one to the original, so the ratio is going to be 3 to 1 because this length is 1 and this length is 3, so it's 3 to 1. And the perimeter is 18 to 6, which reduces to 3 to 1. And the area is 18 to 2, which reduces to 9 to 1. So from the third one to the original, the third one has a side length of 4. The original one had a side length of 1. So the ratio of the perimeters is 24 to 6, which is 4 to 1. And the ratio of the areas is 32 to 1, or 32 to 2, which is 16 to 1. So down here, how do the ratios of the perimeters and the areas compare with the similarity ratio? So the similarity ratio is the same for the perimeter. It's the same, but it's different for the area. So I'm going to write the perimeter ratio is the same. Okay, then we have to look at what are we doing with the area? So what is the pattern? What is the pattern of these if the ratio is 2 to 1 and the area is 4 to 1? The ratio is 3 to 1 and the area ratio is 9 to 1. The ratio for similarity is 4 to 1 and this is 16 to 1. So the area ratio is squared. 4 squared is 16, 3 squared is 9, 2 squared is 4. So you have to square the ratio. So the theorem is if the similarity ratio of two figures is A over B, so if this is your fraction A over B, the ratio of the perimeters is A over B. It's the same. The ratio of the areas is squaring them. So you have to square the similarity. Okay, then example 1. The trapezoids below are similar. Find the ratio smaller to larger, so make sure that you're paying attention to which one you're supposed to write first, of their perimeters and their areas. So I can tell that this similarity ratio from smaller to larger is 3/9. You could also write it as 3 to 9, but we want to reduce this and write it as 1/3 or 1 to 3. So I'm going to write it as 1 to 3. The ratio of the areas is square them. So it's going to be 1 squared over 3 squared, or 1 to 9. So the ratio of the areas is 1 to 9. Number 2. Two similar polygons have corresponding sides in ratio 3 to 7. Find the ratio of their perimeters and areas. So remember, the perimeter is going to be the exact same, so 3 to 7. The area is going to be 3 squared to 7 squared. So 3 squared is 9, 7 squared is 49, so it's 9/49. Or 3/7 if you want to write it as fraction instead. Okay, so now we're going to use this to find missing areas. So two figures are similar below. Find the area of the larger figure. So first what we need to do is find the similarity ratios. So 12/5 is a similarity ratio, which means that the area ratio is 12 squared over 5 squared. So now I'm going to set up a proportion, not with the similarity ratio, but I'm going to set up a proportion with the area ratio. If this was perimeter, I could just use 12/5, but I need to use 12 squared over 5 squared. So it's going to be 144, because that's 12 squared, is 225, as, now this is the smaller figure area, so I'm going to put that on the bottom with the smaller figure, 20 over x. So now I'm going to cross multiply. So when I cross multiplied, I get x equals 115.2 inches. So a common mistake is to set up the proportion without using the area ratio by squaring these. So I see people do 12:5 as x is to 20. No, it's 12 squared. So let's look at the second one. So I'm going to set up my area ratio again. So 7 squared is to 15 squared, as, well, this area goes with 80, the 7 goes with 84, 7 squared goes with 84, so 84 is to x. So now I'm going to cross multiply and do 49x equals 225 times 84. So 18,900, divide both sides by 49. So it's about 386 centimeters squared. I rounded. Okay, and then the next part. The two similar figures are given, so we know they're similar. Find the ratio of the perimeters. Okay, this time the areas are given. So in order to find the similarity ratio, we need to write smallest to largest, so it's going to be 12 over 27. But this isn't the similarity ratio, this is the area ratio. So to get the area or similarity ratio, you have to take the square root. So it's the square root of 12 or the square root of 27. So if I simplify the square root of 12, it's 2√3. If I simplify the square root of 27, it's 3√3. These cancel out, so it's 2 over 3. 2/3 the similarity, or the ratio of the perimeters. Okay, then the second one, smallest to largest, so it's going to be 1 over 4. But this is the area ratio, so to get the ratio of the perimeters, you have to take the square root. So it's 1 over 2. That one worked exact. Okay, and then the end, find the similarity ratio of each set of similar figures. So these have areas. These are all areas, so it's the first one's going to be 8 over 32, and then you're going to take the square root of both of them, So the top is 2 root 2 and the bottom is 4 root 2. These cancel out, so it's 1/2. And the second one is the square root of 81 over the square root of 25, which is 9/5. And then the third one is square root of 10 over the square root of 360. So this is the square root of 10 over 6 root 10, which is 1/6. And then the last one is the square root of 128 pi over the square root of 18 pi. So this is 8 root 2 pi over 3 root 2 pi. These cancel out, so it's 8/3. So if you know the area ratios to find the similarity ratio or the perimeter ratio, you just take the square root.